Thank you, Ms. Nell. Hello, everyone. I'm here to present our study, Big Data in the Philippines, How Do We Actually Use Them, which was recently published in the Statistical Journal of the International Association of Official Statistics. So, cognizant of the need to generate high-quality, timely, and more granular data required in monitoring national development plans and agendas, national statistical systems are now looking for alternative data sources. It is now increasingly recognized that traditional statistical approaches and data collection methods may have to be complemented by exploiting new and innovative data sources. One such alternative source that is currently a subject of enormous interest among statistical bodies is big data, the term coined for large amounts of complex data produced at high speed, brought about by the advancement of technology, digitalization, and boom of the internet. Big data has now come to be seen as one solution that could fill data gaps, resolve data lags, and provide data more efficiently, in a timely manner, and with greater detail, a could be considerable change to the world of official statistics. This study looked at the various definitions of big data, the type of information it has, and the corresponding data sources, its utilization across countries and most especially in the Philippines, its opportunities, and its challenges and risks. We conducted desk research, focus group discussions with the private sector and the academe, and key informant interviews with the public sector and development finance institutions to gather a myriad of information. Ultimately, we use these findings to propose a framework for big data in official statistics. For the definitions, we find that big data has really no exact definition. However, there is consensus that big data can be described depending on its use or consumption, the evolution of tools and techniques used, and the required skills for analyzing and extracting data. Big data is different from traditional data in the sense that it cannot be processed using conventional tools and software and requires specific technological and analytical algorithms for its transformation into value. It covers a wide base and is comprised of a combination of different data points and data types. We have identified three types of big data with corresponding variety of data sources. First, we have the human source information, which is composed of records of human experiences. This is usually loosely structured and often ungoverned. Second, we have the machine-generated information, which is derived from the phenomenal growth in the number of sensors and machines used to measure and record events and situations. This is usually well structured. Third, are process-mediated information, which includes transactions such as metadata. These are highly structured in nature and is commonly stored in relational database systems. All these big data types can be found in various sources, such as but not limited to social media and networks, smart devices, emails, images, transaction records, videos, locations, sensors, and databases. These big data types are utilized for varying purposes across countries. First, we have the web scrape prices and price records from supermarkets and retail outlets, which are used to measure price index and inflation, whereas sentiment data and social media data are used to measure tourism. We also have satellite data, remote sensing data, drone imageries, and aerial imageries, which are used for agricultural monitoring, agricultural statistics, land statistics, and population mobility. Crime statistics are complemented with data from call records. We also have here Google Trends and business records, which are used for economic statistics and national accounts, and patient registries, photos and videos, mobile phone data, custom records, social media, and location data, which are used for disaster surveillance and tracking of the spread of diseases. In the Philippines, some noted utilization of big data are the use of satellite data for crop insurance, remote sensing processing, and analysis for rehabilitation of bays, remote sensing methodology for forest cover and forest covered mapping, and mapping of coastal aquaculture and fisheries structure. We also have the use of geographic information system data and space technology data for disaster risk reduction, and the use of location data and satellite imagery to track and visualize project implementation studies. And lastly, the use of transportation data to produce near real-time traffic data and statistics including speed, flow, and delays at intersections to study critical areas in traffic management. These various utilizations of big data observed show that there are significant opportunities of big data. In our study, we find this as follows. First is that big data can help monitor the Sustainable Development Goals or SDGs. Some SDG indicators that could utilize big data are SDG 5B.1, where we can use mobile phone users' data from telecom companies to measure the proportion of individuals with mobile phones. We also have SDG 11.2.1, where we can use sentiment data and opinion mining from location-aware social media and mobile applications to measure the proportion of the population with access to public transport. And also SDG 16B.1, where we can use social media data and mobile phone users' data to measure the proportion of the population reporting discrimination or harassment. Second is that big data can complement official statistics and support core national statistics. Some official statistics that could be complemented with big data are civil registration and vital statistics, statistics on tourism, agriculture, health, price, environment, social protection, and transportation. Third, and ultimately, big data can help improve service delivery, policy making, and decision making. It is advantageous in achieving a government that is data powered or data driven when it comes to decision and policy making. Although there are significant opportunities in big data, challenges and risks also exist. First is awareness. The lack of awareness and understanding of big data can be a major stumbling block for big data adoption. It results in a disinclination to adapt to new methods and technologies. Second is cost. Big data can be costly in terms of infrastructure, manpower, and technological requirements. A solid and complete big data infrastructure is also needed. There is also high cost to acquiring big data, even with its open source solutions. Third is skills. Big data requires new skill set, and since new tools have been introduced, this requires more advanced analytical skills. Various new areas of expertise are also needed to leverage the information contained in big data. Fourth is quality. Working with big data has limitations. There is a lack of quality framework available that will indicate the quality or credibility or screen the certainty or accuracy of big data. The reliability of estimates and representativeness of the sample must be well examined. Challenges in determining the quality and veracity of big data remain. Fifth is confidentiality. With big data having a wide scope, various types, and coming from so many sources, privacy issues are eminent. Personal information or transactions are at risk of exposure to the wrong hands. Sixth and last is security. Big data use comes with the risk of breaching data privacy and confidentiality and data sharing protocols. Ethical issues in data use are also a challenge. There is a need to ensure that access to information will not be prone to abuse and misuse. With the findings from the task research, focus group discussions, and key informant interviews, we proceeded to propose a framework for big data in official statistics. The core objectives of the framework is to provide a holistic structure for leveraging big data in official statistics and for the Philippine statistical system to benefit from the many potential and opportunities of big data. It must be a requisite for any organization planning to utilize big data to equip itself with awareness on the current environment of big data and before fully embarking on adoption, There must be a consensus on the definition that the organization will follow to ensure that every big data actor has the same level of understanding and to avoid deviations from the organization's big data adoption objectives. Moreover, the organization needs to select the right manpower to perform collection and ensure that what is needed is intended to be used and produced. Further into big data collection, collaboration should be promoted across the public and private sectors to enable data sharing and leverage data lakes. What is needed are standardized and ethical data sharing protocols with private companies and data owners. Forging partnerships among data producers and enablers by clearly outlining roles and responsibilities can foster a sustainable big data ecosystem. Sorting the vast information, picking up the ones that met the organization's needs, and removing noisy information is likewise a must in ensuring that the data is of quality, accurate, right, and makes sense. Data verification and quality benchmarks, and data sharing, privacy, and confidentiality agreements must be fully adhered to avoid data misuse and breaches. In analysis, the most suitable tools and techniques to efficiently utilize big data and to inform conclusions and support decision making must be a priority to ensure that meaningful insights are extracted and that the value of big data is fully harnessed, including hidden patterns and unknown correlations. Big data, when organized, processed, and analyzed adequately, can be valuable, and measuring the value created is a boundless process with endless options of data types, data sources, and data methods. Value creation, however, does not end in generating insights. Transforming data insights into actions that lead to identifying new opportunities for an organization to better its services creates value. But beyond creating value for the organization, a collaborative strategy of creating a diversified and dynamic knowledge base by being an enabler in an interconnected data network allows for more sustainable value creation opportunities that is not limited to the internal organization alone, but the entire big data ecosystem. Further, big data analysis and visualization, coupled with outputs and reports generated, must be communicated and delivered to stakeholders for actionable insights and data driven decisions, especially for priority statistics deemed to be the most current and immediate need. This is our proposed framework for the adoption of big data in official statistics. With that, this study concludes that as technology and society progresses, the potential of big data as the answer to the growing demand of generating real-time and granular data for better decision-making process and problem solving is becoming more and more evident. Access to big data can help resolve the limitations of traditional data. Many of these benefits relate to the economical and foster access to a wide new range of data sources and analytical tools, and a reduction in the efforts and constraints imposed by traditional data collection methods. Big data can complement official statistics. However, pertinent challenges and risks must be considered, mitigated, and resolved prior to adoption. And then this study finds the following as needed considerations to enable big data adoption in official statistics. These are modernizing and strengthening the statistical system as a key in alleviating the challenges of big data, taking an initiative to introduce big data related programs in the educational systems as a starting point to big data awareness, scaling up information technology capabilities through capacity building, and improving and reinforcing data privacy laws to prevent data breaches from occurring. Moreover, partnerships with the private sector to forge the sharing of big data that is also within an environment where privacy issues and concerns are mitigated and confidentiality protocols are met must be established. The way forward for big data as complement in official statistics includes support and collaboration between sectors, and reinforcement of the existing legislations. The findings of the study, the proposed framework, the conclusions, and the recommendations only serve as a guide in getting started with big data as a complement to official statistics in the Philippines. They are but suggestive of what the essential elements of an approach to big data adoption should entail, as the use of big data necessitates a strategy to select the most productive applications to complement official statistics and bring added value, such as improved timeliness, bridging existing data gaps, and providing more granular data. The overall assessment conducted in this study will also need to be revisited as big data and official statistics continue to evolve. Consequently, the framework is considered not static, but living and dynamic, and will also continue to improve. This concludes my presentation. Thank you very much, everyone, for listening, and have a good day.